Hello everyone, my name is Rehan and I welcome you all to the platform of Infinity Vision. In this maths concept video, we are going to talk about four concepts of a triangle. We'll begin with what is circumcenter. Second, we are going to talk about what is incenter. Third, we are going to talk about what is centroid. And last but not the least, we are going to talk about what is orthocenter. As you can see, you have a triangle, and in a triangle you have three sides and you have three vertices and you call them A, B and C, and you have three angles, angle A, angle B and angle C. Let's begin with this line segment. Let's call this line segment as BC. If you want to divide this line segment in two equal parts, you got to plot midpoint of this line segment BC, and we are going to call this midpoint as D. Now you can say this midpoint D divides line segment in two equal parts. So in other words, you can say D bisects line segment BC. Now through this midpoint D, we are going to plot a perpendicular line to this line segment BC. Now this perpendicular line has two roles to play with respect to BC. That one is that it is perpendicular to BC. The second, it is passing through the midpoint, which means this line bisects your line segment BC. So you have a name for this type of line. You call this line as perpendicular bisector because it is perpendicular as well as it is bisecting your line segment BC. Now considering line segment BC as a side of a triangle, let's draw a triangle. Now you have a triangle ABC. So the other two sides are AC and AB. Now looking at the line segment AC, we can again draw the midpoint of line segment AC likewise. So you can say this point, and let's call this point as E, and you can say E is the midpoint of AC. You can say E bisects AC. In the same fashion, we can plot the midpoint for line segment AB, and let's call this point as F. So you can say F bisects AB. Now through E and F, we are going to draw perpendicular lines, which means we are going to draw the perpendicular bisectors of AC and AB. When you will plot the perpendicular bisectors, you will notice that all the three perpendicular bisectors are passing through a common point. In Euclidean geometry, whenever you see three or more than three lines passing through a common point, you call them concurrent lines. So you can also say your perpendicular bisectors are concurrent. And you will notice this point of concurrency, the point where all the three perpendicular bisectors are meeting, you have a name and you call this as circumcenter. So if anybody asks you, what is circumcenter of a triangle? You're just going to say that in a triangle, you have three sides. So you can have three perpendicular bisectors. The point of intersection of perpendicular bisectors of a triangle is called circumcenter. And usually we denote circumcenter by letter O. I hope you will never feel uncomfortable whenever you hear this word circumcenter. Now moving from the story of circumcenter, we'll move to the story of incenter. Now you have this triangle ABC. So you have this angle A. Now through vertex A, we are going to plot ray AX, which will divide this angle in two equal parts, something like this. So you have this ray AX, which divides internal angle A in two equal parts, or you can say bisects internal angle A. So you have a name for this. You call this as internal angle bisector. Since you have other two angles as well, angle B and angle C, so you can have two more internal angle bisectors. So when you plot them, again you will notice that your internal angle bisectors are concurrent, which means they are passing through a common point, and you have a name for it, and you call this point as incenter. So if anybody asks you what is incenter of a triangle, you are going to say there are three angles, so there would be three internal angle bisectors. The point of internal angle bisectors of a triangle is called incenter, and we denote it by letter I. Now moving from the story of incenter to the story of centroid, let's say you have a triangle ABC and you have this vertex A. Opposite to vertex A, you can see you have a line segment BC, which you can say the side BC. Now let's try to plot the midpoint of line segment BC, and let's call this point as point D. Now connecting vertex to the midpoint of opposite side. Now this line segment has a name, and you call this line segment as median. So if anybody asks you what is median, you can say if you connect vertex to the midpoint of opposite side, that line segment is called median. So you have B, you have C. So the line segment opposite to B, or the opposite side opposite to B, is AC. So you can say the midpoint of AC is E, and similarly you can say the midpoint of AB is F. So if you connect B with E, you will get another median, and when you connect C with F, you will get another median. So you will have three medians, and again you will see that all the three medians are concurrent, which means they are passing through a common point, and you call this point, you have a name for it, and you call it centroid. If someone asks you what is centroid, so centroid is you have three medians, so the point of intersection of medians of a triangle is called centroid, and we denote centroid by letter G. Now moving to our last story, the story of orthocenter. You have a triangle ABC. Now through vertex A, you can drop the shortest distance to BC through a perpendicular line. So when you drop a shortest distance from A to BC, you call this line segment as perpendicular line, or altitude or height. So if someone asks you what is altitude and height of a triangle, so from vertex to the shortest distance to the opposite side or a perpendicular line, that line segment is called altitude. Since you have other two vertices, that is B and C, so you can drop two more altitudes to their respective opposite sides. So you can say that you have this two line segment BK and CL. Now when you notice that all the three altitudes are again passing through a common point, which means they are concurrent, and this point of concurrency has a name, and you call this point as orthocenter. So if someone asks you what is orthocenter of a triangle, what you're going to say? You're going to say that orthocenter of a triangle is the point of intersection of altitudes of a triangle. So you have three altitudes, so the point of intersection of three altitudes is going to be called as orthocenter of a triangle. And you denote this orthocenter by letter H. So we talked about circumcenter, which is denoted by letter O. We talked about incenter, which is denoted by letter I. We talked about centroid, which is denoted by letter G, and we talked about orthocenter, which is denoted by letter H. And you know, perpendicular bisectors, the point of intersection of perpendicular bisectors is called circumcenter. The point of intersection of internal angle bisector is called incenter. The point of intersection of medians is called centroid, and the point of intersection of altitude is called orthocenter. I hope you will not forget. Always try to map perpendicular bisector with circumcenter, internal angle bisector with incenter, median with centroid, and altitude with orthocenter. So in the next video, we are going to prove that why perpendicular bisectors are concurrent. So see you in the next video. Bye bye. Take care.